Good morning. I welcome all of you. I am V.Srinivasa Reddy, Associate Professor of Mathematics, Government Degree College, Ramannapet. This is the fourth video lesson on real analysis, and overall it is the 29th video lesson in this season. Today I will talk on infimum, supremum of a sequence, and when we say sequence, it's called monotone sequence. So today our class is infimum and supremum of a sequence. Before going to that, I will define infimum and supremum of a set. And increasing sequence, when you say sequence, is called increasing, and decreasing sequence and monotone sequence. So before going to define infimum, supremum of a sequence, I will define lower bound, upper bound of a set, and infimum and supremum set, and then I will go to the infimum of a sequence. When you say lower bound, what is the meaning of lower bound, upper bound of a set? Suppose S is a subset of R. Let S is a subset of real. R means a set of real numbers. Let S be a subset of R. So a real number L is called lower bound for a set S if X greater than equal to L or L less than equal to X for all X belongs to X. So a real number L, here it is L, is called lower bound for a set S if X greater than equal to L for all X belongs to S or L less than equal to X. That means every number of S is greater than equal to L. So in that case, we say that L is called the lower bound. Here, lower bound. Every number is greater than equal to L. So upper bound means a real number U is called upper bound for a set S if X is less than equal to U for all X belongs to S. That means every number of S is less than equal to U. So upper bound means, so in every number in the set S is always less than equal to U, then U is called upper bound for the set S. Lower bound means every number in the set is greater than equal to L. So what is the meaning of infimum of S? This is called greatest lower bound. Greatest lower bound. So once if a set has a lower bound, it has so many lower bounds. So among all the greatest number is called the greatest lower bound. So greatest lower bound, this can be written as simply we can write GLB. So here lower bound means simply LB, lower bound. Upper bound means UB, simply upper bound. So greatest lower bound means simply GLB or infimum of S is so the maximum number of all upper bounds of a set S is called greatest lower bound or infimum of set S, or the greatest number of all lower bounds of a set S is called greatest lower bound. In definition itself is there that the greatest number of all lower bounds, the greatest number or maximum number of all lower bounds of set S is called GLB. That means the greatest lower bound or infimum of set S. Another definition is a real number M is called infimum of set S if first condition it is a lower bound. So in definition itself is there, infimum of S is greatest lower bound. If M is lower bound. Second one is any number greater than M is not lower bound for S. Any number greater than M is not a lower bound for S. So M is lower bound, any number greater than M is not a lower bound for S, then M is called the infimum or greatest lower bound of S. Because it is M is the greatest lower bound, that's why in the definition any number greater than M is not a lower bound for S. Similarly, least upper bound, LUB, this is called LUB. LUB means least upper bound, LUB, or supremum of S. The definition itself is there. The least number of all upper bounds of set S is called least upper bound or supremum of set S, or supremum of set S. So once in general, actually if S has the upper bound, it has so many upper bounds, because suppose U is an upper bound, any number greater than U is also upper bound. That's why if a set has an upper bound, it has so many upper bounds. Among all these, the least number is called the least upper bound or supremum of S. In definition itself is there, the least number of all upper bounds of set S is called the least upper bound or supremum. So least upper bound can be written another way is a supremum, least upper bound, or it is called supremum of set S. Another definition, here same thing. The real number M is called supremum or least upper bound for S. When you say real number M is called the supremum or least upper, LUB means least upper bound for S. If one M is definition itself is the least upper bound. M is the upper bound for S, and any number less than M is not upper bound for S because it is the least. Capital M is the it is the least number of all upper bounds. That's why, and any number less than M is not a upper bound for S. Here it is the greatest. That's why here we have written any number greater than M is not a lower bound for S. Finally, so least upper bound means it is an upper bound, and any number greater than any number less than M is not upper bound for S. Greatest lower bound means it is lower bound, and any number greater than M is not a lower bound for S. This is the set. In general, any lower bound always less than equal to upper bound for any set, whatever it may be. Lower bound for a set, lower bound always less than equal to upper bound. Why? Because this. Suppose L is a lower bound, what happens? L less than equal to X. U is upper bound, X is less than equal to U. So every number is greater than equal to L. That's why L less than equal to X. And upper bound means X less than equal to. From these two, L less than equal to X less than equal to. So we'll get L less than equal to U. That's why any lower bound always less than any upper bound for a set. And also infimum always less than equal to supremum. Suppose if M and capital M are infimum and supremum set S respectively, then M is less than equal to X by definition, because M is infimum means it is the greatest lower bound. M is lower bound. Lower bound means M less than equal to X. Small M less than equal to. M is upper bound because supremum means it is an upper bound and it is also least upper bound. So M less than equal to X less than equal to capital because it is an upper bound. So X every term in the every number in S always is equal to M. So and another, if L is lower bound of S and L belongs to S, then automatically L equal infimum of S. If U is any upper bound of S and U belongs to S, then U is equal to supremum of S. These are some important points. Now, this is the definition for a set. How can we define for the a sequence? A sequence for the lower bound, sequence for upper bound. So sequence for a lower bound and a sequence for a upper bound. So here a real number L belongs to R is called lower bound for the sequence Sn if Sn greater than or equal to L. If Sn greater than or equal to L, that means every term in that equation always greater than or equal to L. Or you can write this L less than or equal to Sn. This is here the sequence Sn. Here L is called a lower bound. So a real number L is the lower bound for the sequence Sn if Sn greater than or equal to L. So every term in the sequence Sn is greater than or equal to L, then the number L is called the lower bound. And here the sequence Sn is called the bounded below. You know, already I defined in the last class, bounded below means if Sn greater than or equal to K1 some number, then Sn is bounded below. That's why every term in the sequence Sn greater than or equal to L. So here it is a bounded below. So and L is called a lower bound. And upper bound means same in the set what we defined in the set X less than U for all X belongs to S. When you say a number U is called upper bound for a set, if X less than U for all X belongs to U, for all X belongs to S. So defined here upper bound for a set if X less than U for all X belongs to S. Similarly, for the sequence Sn less than U, Sn less than U. So a real number U belongs to R is called upper bound for the sequence Sn if Sn less than U for all N belongs to U. So here the sequence is bounded above because it is bounded by U. So bounded above by it is every term in the sequence less than U. That's why here the sequence is bounded above. When the sequence has upper bound, then it is bounded above. When the sequence has a lower bound, it is bounded below. Or if the sequence is bounded below, it has a lower bound. If it is bounded above, then it has a upper bound. So we see one simple example on lower bound, upper bound, and also. So for example, Sn equal to 1 by n. So we write Sn is equal to S1, S2, S3, and so on. So for n is equal to 1, you'll get 1 by 1, 1. For n is equal to 2, we'll get 1 by 2. For n is equal to 3, we'll get 1 by 3. So we'll get 1, 1 by 2, 1 by 3. Clearly, every term in that equation, Sn greater than 0 for all n belongs to n. Clearly, you observe here. Sn is greater than 0 for all n belongs to n. Because n is natural number, n belongs to n. So 1 by n is positive. Therefore, 0 is the lower bound for sequence Sn. So every term in this equation, in this sequence, greater than 0. So clearly Sn greater than 0. And the 0 is the lower bound for the sequence Sn. And also we observe that in this equation, every term is less than or equal to 1. So every term is less than equal to 1, Sn less than equal to 1 for all n belongs to n. Every term in the sequence, in this sequence less than equal to 1, therefore 1 is upper bound for the sequence. So here, every term in the sequence is greater than 0, therefore it is an lower bound. And every term in the sequence is less than equal to 1, it is an upper bound for the sequence. Another note point. If L is the lower bound of Sn, then any number less than L is also lower bound for Sn, for the sequence Sn. Here I am writing like this, it is a sequence. If L is lower bound of sequence Sn, then any number less than L is also lower bound for the sequence Sn. Because here we observe that 0 is a lower bound for sequence Sn. So if you take any number less than 0, for example, if I take minus 1 is less than 0, so then automatically Sn greater than minus 1 for every n. So that's why minus 1 is also lower bound for Sn. So here 0 is lower bound. Any number less than 0 is also lower bound. Okay, suppose take a number less than 0, for example, minus 1. So now Sn greater than minus 1 for all n plus 10. Therefore, minus 1 is also lower bound for Sn. So this is the one point. If L is the lower bound of sequence Sn, then any number less than L is also lower bound for Sn. And also another, if U is upper bound of Sn, here UB means upper bound, LB means lower bound. So then any number greater than U is also upper bound of Sn. So if U is upper bound of sequence Sn, then any number greater than U is an upper bound of sequence. For example, here 1 is an upper bound for the sequence. You take any number greater than 1 is also an upper bound. Suppose you take a number greater than 1, for example 3. 3 is greater than 1. Now 3 is also upper one because every term in the sequence Sn less than 4 for all n belongs to n. Sn less than 3 for all n belongs to n. Therefore 3 is also upper bound of the sequence. So U is an upper bound for the sequence Sn. Then any number greater than U is also an upper bound. So you take any number greater than 1 is also an upper bound for this sequence. For example, 4 is greater than 1. So then automatically every term Sn less than 4 every term because it is always less than equal to 1. This is less than 4. So if U is an upper bound of Sn, then any number greater than U is also an upper bound of Sn. So okay, next, infimum of a sequence or greatest lower bound. So infimum can call greatest lower bound. Already I defined for the set. The greatest number of all lower bounds of a set S is called the infimum of a set. Similarly, we can define the greatest number of all lower bounds of sequence is called infimum of sequence. We take the all lower bounds of the sequence and the greatest number of all the lower bounds, that is called infimum, or this is called greatest lower bound, GLB. GLB means greatest lower bound. So GLB means greatest lower bound. So infimum of a sequence or GLB means greatest lower bound. So simple. The greatest number of all lower bounds of sequence is called infimum of sequence. So infimum means the greatest lower bound. All the greatest number of all lower bounds of sequence is called the infimum of sequence. So another way this can be defined. A real number M is called infimum of sequence M, infimum of the sequence Sn, whatever it may be, infimum of a sequence. If number one first condition is M is the lower bound of sequence. So here infimum means GLB. GLB means greatest lower bound. So first condition is M is the lower bound of sequence, and any number M and any number greater than M is not lower bound of sequence. The first condition is, so when you say M is called infimum or greatest lower bound, GLB, of a sequence Sn, if M is the lower bound of the sequence Sn, and any number greater than M is not a lower bound of sequence, because M is the greatest lower bound, that's why any number greater than M is not a lower bound of the sequence. Similarly, we define supremum or least upper bound of a sequence, LUB, supremum or least upper bound of a sequence. Already we defined in the set, what we defined in the set, supremum. In the set, a real number capital M is called supremum or least upper bound for S. If M is a upper bound for S and any number less than M is not upper bound for S. Why? Because this is not upper bound. Capital M is the least upper bound. That's why any number less than M is not upper bound for S. Similarly, we define here a real number capital M is called supremum or least upper bound for sequence, given sequence Sn, if first m is the upper bound of that sequence, and any number less than m is not upper bound of sequence. This is important. First, it is upper bound. Any number, capital M is not upper bound of sequence. Why? Because it happens because this m is the least upper bound. That's why any number less than m is not upper bound of sequence. So, the first point is a real number m is called supremum for a sequence. If capital M is the upper bound of sequence, and any number less than m is not upper bound of sequence. Here for the infimum, a real number m is called, small m is called infimum of sequence. Infimum of sequence. If m is the lower bound of sequence, and any number greater than m is not a lower bound of sequence. So here m is lower bound, and any number greater than m is not a lower bound of sequence. Here it is GLB, greatest lower bound, or infimum. Here least upper bound. That's why a real number capital M is called supremum or least upper bound for a sequence. If capital M is a upper bound of sequence, and any number less than m is not upper bound of sequence. So if small m, capital M are infimum and supremum of sequence Sn respectively, then small m always is equal to Sn less than equal to m for all m belongs to m. You know, m is infimum means it is a lower bound. So every term in the sequence Sn greater than equal to m, that is m less than equal to Sn. Capital M is supremum means it is in a least upper bound, it is m upper bound. Upper bound means every term is less than equal to m. So m less than equal to Sn less than equal to m for all m belongs to m. Now we see one example on infimum and supremum. So let Sn equal to 1 by n. Now sequence Sn can be written as S1, S2, S3, S4 and so on. So if you write n is equal to 1, 1, n is equal to 2, 1 by 2, n is equal to 3, 1 by 3 and so on. So n is equal to 4, 1 by 4. You observe this, every term in that equation is greater than 0 and every term in this sequence is less than equal to 1. So clearly 0 less than Sn less than equal to 1 for each n. So you observe here, every term, because n belongs to n, this is Sn greater than 0 for all n. So S0 less than Sn and every term less than equal to 1. So less than equal to 1 by 1 for each n. So therefore, now 0 is lower bound, 1 is upper bound for the sequence. And also observation, any number greater than 0 is not a lower bound of sequence. Any number greater than 0 is not a lower bound of the sequence. Therefore, infimum of Sn is 0. And supremum of Sn is automatically 1 because 1 also belongs to this set. It belongs to the sequence Sn. Therefore, supremum of sequence Sn is 1. So, for this set, 0 is a infimum or supremum set. Infimum or supremum sequence may or may not belongs to the range. Or may not belong to the term of the sequence. So here 1 is there, but 0 doesn't belong to Sn. So, but 0 is an infimum. So finally, we are getting here for this 0 is lower bound, 0 is an infimum, and 1 is a supremum. 1 is supremum of Sn. Because if you take any number less than 1 is not upper bound. And also supremum Sn equal 1 because 1 belongs to Sn. So, and also another important completeness exam, you can use so many theorems. Every non-empty subset of R which is bounded above has a supremum. So if S is any non-empty subset of R, it is bounded above, then it has supremum. And also similarly, every non-empty subset of R which is bounded below, as infimum. So every non-empty subset of R which is bounded above has supremum. Every non-empty subset of R which is bounded, if it is bounded below, it has a infimum. That set has a infimum. That means so infimum here it is Mr. GLB. You see this is GLB, greatest lower bound. It is okay. Least upper bound you have to write here GLB. Infimum means GLB. Okay. Every non-empty subset of R which is bounded below has infimum, that is greatest lower bound. GLB. That's right. And we see next. When you say sequence is called increasing sequence, and then we go for decreasing sequence, and we go for monotone sequence. First, we will define when it is a sequence, Sn is called increasing. A sequence Sn is called increasing if Sn plus 1 greater than Sn for all n belongs to n. So a sequence Sn is called increasing sequence if Sn plus 1 greater than Sn for all n belongs to n. Or another way, a sequence Sn is called increasing if S1 less than equal S2, less than equal S3, less than equal S4, and less than equal S4. It is an increasing order. The terms are, the sequence are increasing order. So S1 less than equal S3, less than equal S2, less than S4. If the terms in the sequence S1 are increasing order, then the sequence is called increasing. So one definition is if Sn plus 1 greater than equal Sn for all n belongs to n. Another definition is a sequence Sn is called increasing if S1 less than equal S2, less than equal S3, less than equal S4, less than equal and so on. So another definition, the sequence is called increasing if Sn less than equal Sm when n less than. Well, for example, 3 less than 4. So S3 less than equal S4. 2 less than 3. So S2 less than equal S2. Another way is a sequence is called increasing if Sn less than equal Sm when n less than m. And also we observe it, every increasing sequence is bounded below, because we observe every term that sequence is greater than equal to S1, Sn greater than equal to for each n. You observe it. S1 less than equal to S2 means S2 greater than equal to S1. And S1 less than equal to S3 means S3 greater than equal to S1. S1 less than equal to S4 means S4 greater than equal to S1. So every term in the sequence is greater than equal to first term, greater than equal to S1 for each n. So every increasing sequence is bounded below. So here we see increasing means S1 less than equal to S2 less than equal to S3 less than equal to S4. So every term, so from these two, S2 greater than equal to S1. From these two, S3 greater than equal to S1. These two, S4 greater than equal to S1. So every term in the sequence is greater than equal to S1. Therefore, it is a bounded below, and you see that this S1 is a lower bound for the increasing sequence. First term is the lower bound for the sequence Sn, because when it is increasing. So this is like Sn greater than equal to L for each n. So now S1 is a lower bound for the sequence, for the increasing sequence Sn. So whenever sequence Sn is increasing, then it is always bounded below. Decreasing sequence. So here the sequence, and also we define like this also. The sequence Sn is called increasing if Sn plus 1 minus Sn, if you take left hand side, Sn plus 1, Sn greater than equal to 0. And another way, similarly, just signs will be changed. Here greater than equal to, here less than equal to. So a sequence Sn is called decreasing if Sn plus 1 less than equal to Sn for each n. And our sequence Sn is called a decreasing sequence if S1 greater than equal to S2 greater than equal to S3 greater than equal to and so on. These are in decreasing order. If the terms are in a decreasing order, so the terms in the decreasing order. So here we observe it, S1 greater than equal to S2 greater than equal to S3 and so on. So decreasing, values are decreasing. So S1 is S2 is lower than S1, S3 is lower than S2, S4 is lower than S3. So if it is a decreasing order, then the sequence is called decreasing sequence. So the sequence is Sn is called decreasing if Sn plus 1 less than for each n. Our sequence Sn is called decreasing. Another definition, S1 greater than S2 greater than S3 greater than S3 and so on. So here we observe every decreasing sequence is bounded above, because we observe it. S1 greater than S2 means S2 less than S1. Yeah, and S1 greater than S3 means S3 less than S1. Every term in the sequence is less than equal to S1. So we observe here. If you take these two, S1 greater than S2 means S2 less than S1. If you take these two, S1 greater than S3 means S3 less than S1. So first every term is less than equal to first term. Therefore, every decreasing sequence is bounded above, since Sn less than equal to S1 for all n. For all n. So you observe, if it is increasing sequence, every increasing sequence is bounded below, and S1 is a lower bound. And every decreasing sequence is bounded above by S1, and S1 is the upper bound for the sequences. So when Sn is a decreasing sequence, then S1 is the upper bound for the sequence. And also another definition, when we say sequence Sn is called strictly increasing if Sn plus 1 greater than Sn, and strictly decreasing if Sn plus 1 is less than Sn. That means, so it is called decreasing sequence if S1 greater than S2, greater than S3, greater than S4, and so on. So it is strictly increasing if S1 less than S2, less than S3, less than S4, and so on. So the sequence Sn is called strictly increasing if Sn plus 1 greater than Sn, and strictly decreasing if Sn plus 1 less than Sn for each n. We'll see simple example. Sn equal to n square. So we know S1, S2, S3, S4. S1 is a 1, S2 is 4, S3 is 9. If you take S4 is 16, because S1 is 1 square, 1, S2 is 2 square, 4, S3 is 3 square, 9, S4 is 4 square, 16. You observe, see, these are the increasing order. S1 less than S2 less than S3 and so on. This is Sn is increasing, or we say that it is strictly increasing. Not only increasing, it is a strictly increasing. S1 less than S2 less than S3. We see these are in a increasing order. The terms in the sequence Sn are increasing order. Therefore, Sn is increasing. See another example. Sn equal to 1 by n. Another example. Sn equal to 1 by n. Sn is equal to 1 by n. So sequence Sn, S1, S2, S3, S4, and so on. So 1, 1 by 2, 1 by 3, 1 by 5. You observe all are decreasing. So S1, 1 greater than 1 by 2, 1 by 2 greater than 1 by 3, 1 by 3 greater than 1 by 4. S1 greater than S2 greater than S3 greater than S4, and so on. All these are decreasing in the decreasing order. So therefore, sequence Sn is decreasing. So if Sn is increasing, yeah, this is simple example. Another simple example, Sn is decreasing. We see another example. Interesting. So here, Sn equal to minus 1 power n. Sn is S1, S2, S3, S4. So n is equal to 1, you get minus 1. N is equal to 2 minus 1 square plus 1. N is equal to 3 minus 1 cube. Minus 1 cube means minus 1 into minus 1, 1. Well, again into minus 1, minus 1. Minus 1 power 4, 1. So here Sn is 1 for n is even number, and minus 1 for n is odd. So here we observe it. S1 less than equal to S2. First it is increasing and decreasing, increasing. It is neither increasing nor decreasing. It is not an increasing sequence, not a decreasing. This is called under oscillating sequence. Sequence is also called oscillating. It is not either increasing or decreasing. So Sn is neither increasing or not. It is not an increasing sequence. It is not a decreasing, because here first term is less than second term, and second term is less. So it is not increasing, not decreasing. So that is a sequence Sn is neither increasing nor decreasing, neither increasing nor decreasing sequence. So this is sequence. This sequence is called oscillating sequence. It's oscillating between minus 1 plus 1. That's why it is called oscillating sequence. So simple, you can easily catch it. These are the increasing order. That's why increasing sequence. These are the decreasing order. The terms in the sequence system. So it is decreasing. So, and when you say sequence is called monotone. So a sequence is called monotone sequence or monotonic sequence. Monotonic sequence, if it is either increasing or decreasing. So if it is increasing or, so in other words, it is increasing or decreasing. For example, it is a monotonic sequence because in increasing. It is also monotonic, it is decreasing. It is not monotonic. Third one is not monotonic because it is not increasing, not decreasing. That's why. So third example 3 is not monotonic. So monotonic sequence means a sequence is called monotonic sequence or monotonic sequence if it is either increasing or decreasing sequence. One problem, you see another one. When you say a sequence is called diverges to plus infinity or limit n tends to infinity, Sn equal to infinity. Limit n tends to infinity, Sn equal to infinity. So monotone sequence means when you say sequence is called monotone sequence. So a sequence is called monotone sequence or monotonic sequence if it is either increasing or decreasing. If it is either increasing or decreasing. So here we see first one is increasing, therefore it is a monotonic sequence. Second one is decreasing, it is monotonic sequence. Third one It is neither increasing nor decreasing. This is not monotonic because it is not increasing and not decreasing. That's why it is not monotonic. And see, when you say sequence Sn is called diverges to plus infinity or limit tends to infinity Sn equal to infinity. So this can be happen if, so we know limit Sn equal to S means we know for each epsilon greater than 0 there exists a number n so that mod Sn minus S less than epsilon for all n greater than n. That is for the limit Sn equal to S. So when you say limit Sn equal to infinity, limit Sn equal to infinity. So simply I will write the limit Sn equal to infinity or limit Sn equal to infinity. If for each epsilon, for each m greater than 0, however big number, here m, however big number for each m greater than, there exists a number n such that Sn greater than m for n greater than. So when you take the term Sn, when n greater than n, then Sn is greater than m. So in this case, we write the limit Sn equal to infinity. So here it is a diverges to infinity because infinity is not a real number. So infinity is not a real number. So that's why a sequence Sn is called diverges to infinity or not, or limit Sn equal to infinity if for each m greater than 0, capital M greater than 0, however big, there exists a number capital N such that Sn greater than m for n greater than m. So for example, simple example, limit n tends to infinity n square equal to infinity. So now we have to get a number n such that n greater than n, Sn greater than m. Let m greater than 0. So Sn equal to n square. We need to show Sn greater than m. So Sn greater than, Sn is here n square. N square is greater than m. So therefore the simple as n greater than root m. N greater than root m. So if you take capital equal root m, then so finally Sn is greater than m if n greater than root m. So let n is equal to root m, then the simple as Sn greater than m. Therefore for n greater than m, so therefore let n equal to n, the simple as Sn greater than m for n greater than m. Therefore the simple limit Sn equal to limit Sn equal to infinity. Limit Sn equal to infinity. So definition, limit Sn equal to infinity for each m greater than 0, for each capital M greater than 0, however big it may be, there exists a number capital N such that Sn greater than m for n greater than m. So you get capital N equal to root m. So limit Sn equal to infinity. Similarly, diverges to minus infinity. When you say sequence, Sn is called diverges to minus infinity or limit n tends to infinity Sn equal to minus infinity. Limit n tends to infinity Sn equal to minus infinity. So this means if for each m less than 0, here we take, here it is positive infinity, here negative infinity means here we take for each m less than 0, there is a number n such that Sn less than m for n greater than m. Here it is mistaken. Here n greater than m. Here we have to write for n greater than m. So limit Sn equal to minus infinity for each m less than 0, there exists a number n such that Sn less than m for n greater than m. Here we have to write for n greater than m. For example, limit n tends to infinity minus n is equal to minus infinity. So Sn equal to minus n. So let m less than 0. So Sn less than m, minus n less than m. So taking minus sign two sides, we get a sign will be changed. For example, 2 less than 4, this implies minus 2 greater than minus 4. Minus 2 greater than minus 4. So whenever taking the minus sign both sides, we get a sign will be changed. For example, minus 2 less than 4. 2 greater than minus 4. 2 greater than minus 4. So n greater than minus m, taking capital N equal to minus m, we get Sn less than m for n greater than. Similarly, here definition such that for n greater than m, here we have to write for n greater than m. So you write limit Sn equal to minus, limit Sn equal to minus. So finally, these are the two definitions. In the sequence, Sn is called diverges to minus infinity. That is the limit Sn equal to infinity. Minus infinity means for each m less than 0, there is a number n such that Sn less than m, kept m for n greater than m. Here we have to write for n greater than m. Similarly, here limit Sn equal to infinity means for each m greater than 0, there exists a number capital such that Sn greater than m for n greater than m. This is the today's class. See, once again we see. So monotonic sequence or monotonic sequence is called, a sequence is called monotone if it is either increasing or decreasing. So in a decreasing sequence means if Sn plus 1 less than plus n, the sequence Sn is called a decreasing sequence if Sn plus 1 less than plus n, or a sequence Sn is called a decreasing if S1 greater than equal to S2 greater than equal to S3 greater than so on. Similarly, if it is increasing Sn plus 1 if Sn plus 1 greater than equal to Sn, or a sequence is increasing if S1 less than equal to S2 less than equal to S3 less than equal to S4 and so on. Similarly, what is the infimum means? Infimum means the greatest number, the greatest number of all lower bounds of sequence is called infimum of sequence. Or in other words, a real number small m is called infimum of sequence if m is the lower bound of sequence and any number greater than m is not lower bound of sequence. And supremum, the least number of all upper bounds of the sequence is called supremum of sequence, or a real number capital M is called supremum or least upper bound for sequence if capital M is a upper bound, if capital M is a upper bound of sequence and any number less than M is not the upper bound of sequence. So all these are useful in the next class. So these are the simple definitions. Thank you.